Okay, good evening. Okay, so today, can I silence? So I told you last week, normally after O-level results are silence. Normally after O-level results are coming, there is a reduction in the class because of the students who think that they won't be able to do A-level science or A-level maths based on the O-level results they have got. So there is a reduction, and meanwhile there are some students who come as new students who decide to do math after getting after getting like results that they didn't expect for O levels. So then there are some students even come as new students. So last week there were few new students, and then I just checked it, and today even there are few new students. So today we'll be starting a new lesson. So everyone here should be able to understand that lesson perfectly. And there are like 2 points that when we are doing this lesson, there will be 2 points where we need the previous knowledge, like the knowledge of the previous lessons that we have done so far. But even when we come to that point, I'll be mentioning those theories or the points that we need to know to solve some of the problem. So what I expect here from the entire class today, everyone here, because I will be personally checking when I give a question, a problem, and ask you to solve it. I'll be personally checking that whether you have raised your hands, because everyone here, even though you started maths today, that is even okay. You should be able to do the problems that we are doing today. Simply, you should understand the lesson 100% perfectly because it's a new lesson. Clear? Okay, so today we'll be starting the lesson functions. So write the main topic functions. Write the main topic functions. Okay, silence, silence, silence. Okay, now listen. Pay attention, everyone. Okay, look at the board. Okay, silence. The main unit is functions. Okay, so I told you in this initial set of lessons that we have under. Okay, no silence. In this initial set of lessons that we have under combined maths, there are like 2, 3 lessons that won't be direct, that you won't be getting questions directly for your A-level examination. For example, I told you we just completed inequalities, and inequalities is not a direct question in your A-level exam. And even we did partial fractions. I told you partial fractions, you won't be getting a direct question of partial fractions in your A-level exam. But I told you both inequalities, and even though there is no any direct question from inequalities, when we are doing the problem, when we are doing the lesson modulus inequalities, we require the knowledge of inequalities. So if you don't know inequalities, it's really hard to do the lesson modulus inequalities. And partial fractions, even though it doesn't come as a direct question, when we are doing lessons like integration and series, we need the knowledge of partial fractions. So this functions is a similar lesson. When you take your A-level paper, there is no any assigned question for the functions lesson. Because we have these allocated lessons for question number 11, we have polynomials and quadratic equations. In that way, so there is no any allocated question number for functions. But the knowledge of functions is so important in mathematics. One reason is like, let's say you are pursuing your higher studies in maths, engineering, IT, computer science, any area that is related to maths. You can pursue your higher studies even in management. No? After doing A levels, you can do the CIM, CIMA, or chartered or CIM and go from the management and marketing side. You can do that. So if you go in those areas, you won't be getting functions. But when you are continuing in a math side, it can be the physical science, maths, engineering, computer science, any area, this functions is an important area. Because even still, there are some students like who were in our class and now who are studying in universities, especially in their first 2 years, they're asking me, so can we have a note of functions, the things that we learned under functions and now have been tested in our universities. So this is a lesson that is not only important for your A levels, it's really important for your higher studies, because everyone here, I assume that you will be pursuing a higher studies career related to something maths, engineering, that side. Okay, so make sure that you have a clear note of this, and mark my word and take care of that note, because when you go to the university, that note will be very important for you. Okay, so I'm not telling you to keep all the notes in A-level syllabus. For example, polynomials, when you go to the university, you don't want polynomials. So forget about that. I don't want you to just like keep it like a museum, keep all the notes that you have done, you have written in your A-levels. But this lesson, make sure that you have to keep this safe. Even when you go to the A-levels, you will be hearing these words. Okay, so before starting these functions, there is a word that we need to mathematically explain. It's what is a relationship. So before coming to functions, we need to explain a word called what is a relationship regarding to maths. Okay. So here, let's say we are having two sets. We are having two sets. This is set number 1 and this is set number 2. Okay, this is set number 1 and this is set number 2. And we know in a set we have elements. In a set we have elements. Okay, what do we term as a relationship in maths? Let's say a connection, or it can be a let's use that word. A connection between two sets that relates that relates the elements of one set to the element of the other set is what we term as a relationship. So simply this joining or the connection that connects the elements of one set to the others to the elements of the other set is what we consider as a relationship. So here it's clear we have elements here in set number 1 and we have elements here in set number 2. So these elements in set number 1 has been assigned or has been related to the elements of the other set through this relationship. So this is what we consider as a relationship in maths. So what is a relationship? A relationship is a connection, or let's use the word connection, which connects or which relates the elements of one set to the elements of the other set is mathematically termed as a relationship. Okay, so that is the basic one. Before coming to functions, we need to understand what is the meaning of a relationship. Okay, right in this way, before defining a function, before defining a function, we need to have a clear understanding about a relationship in maths. About a relationship in maths. Okay, then next line, right inside quoted commas. Right inside quoted commas. A connection between two sets. A connection between two sets that relates stroke assigns this slash symbol relates slash assigns elements of one set to the elements of another set is termed as a relationship. Okay, then so that is inside quoted commas 66 and 99, and then just draw this one roughly. We have set 1, we have set 2. So here the elements of this set has been assigned to the elements of the other set used in this relationship. So this is what we term as a relationship. Okay. Okay, so there are four types of relationships in maths. Okay, not the other type of relationships. So in A levels, we got four different types of relationships. So when it like if I ask you what are the types of relationships, you will give me the answers that you know the different types of relationships. For example, like now there are so many words that you use in these relationships. No? Back then means not 1990s, even in early 2000s and early 2010s, mainly like there was only the two types of relationships, whether it is committed or not committed. So committed then casual. But now it's like there are so many different words. Toxic relationship, serious relationship, committed relationship, situationship, then a casual relationship, dating, and there are different words. So I'm not talking about those kinds of relationships. I'm talking about relationships in maths. So in maths, there are four main types. The first one is a one-to-one relationship. One-to-one relationship. Okay, right? Write in this way. So we wrote what is a relationship, and then next line. There are four main types of There are four main types of relationships. Relationships. I know that, right? The first one using a black pen. Using a black pen. Right? This one-to-one relationship. One-to-one relationship. Okay. So what is a one-to-one relationship? The one-to-one relationship is when one element of this set is only related to one element of the other set. So one element is only connected to one element in the other set. One element goes to this one. This one goes to here. This connects to this one, and this one is to here. So simply one to one gives you the idea one to one. So when one element is only assigned or related to one unique element of the other set, we call it as a one to one relationship. Okay, so write the main thing one to one relationship using black pen, and under that write in normal pen. A relationship that a relationship that connects one element of a set, a relationship that connects one element of a set to a unique element of the other set, to the unique element, to the unique to a unique element of the other set. When we started with a relationship, no, how did I start the sentence? A relationship. Okay, so we can end the sentence in that way. A relationship that assigns or relates. What did I say? Connects. Okay, that connects one element of a set to a unique element of the other set. Yeah, so we can end the sentence in that way. Ne? That a relationship that connects one element of a set to a unique element of the other set. Okay, that's all. So you can just write it is known as a one-to-one relationship. So you don't have to repeat it again. Okay, so then draw this one, these two sets. This is set number one and set number two. One element only connects one element, one to one. Okay, so this is one to one relationship. Then write the second one, many to one. So when I do the second one, then you can say the third one and the fourth one even, because you have the idea, many to one. So what is a many to one relationship? In this case, in a many to one relationship, what happens? One like two or more elements, like let's say these two are connected to one element of the other set. All these three has been connected to one element of the other set. So here it's many to one. Like two or more are going towards one element. And meanwhile, there can be this one-to-one relationship. So one-to-one relationship can be anywhere. But we term this as many-to-one because of this special case. There can be a one-to-one situation even here, but we term this as many-to-one because of this special case. Again, one-to-one කියන එක හැමතැනම තියෙන්න පුළුවන්. But this becomes many-to-one because of these two special cases. So what is a many-to-one relationship? A relationship that connects two or more elements of a set with one element, with one unique element of the other set is what we term as the many-to-one relationship. Okay, then tell me what are the other two relationships? It's many to many and one to many. Many to one to many. Okay, write the second one, many to one relationship, and under that write in this way. Write in this way. A relationship that connects. A relationship that connects two or more elements. Two or more elements of a set with a unique element of the other set So you can end the sentence there, of the other set. Okay, then just draw this. So it's a many-to-one relationship. Two or more elements have been assigned or related to one element of the other set. Okay, the third one is one-to-many relationship. Write the third one, one-to-many relationship. So one-to-many is the opposite of the previous situation, where one element, here what happens, one element is connected with two or more elements in the other set. So here one element has been connected with two or more elements. And meanwhile, I told you there can be a one-to-one relationship. So one-to-one relationship can be seen in any kind of relationship. But we name this as one-to-many because that is a special case here. So that is a special case here. Okay. So what is a one-to-many relationship? A relationship that connects one unique element of a set with two or more elements of the other set is what we consider as a one-to-one relationship. Okay. Right under this, a relationship that connects one unique element of a set, relationship that connects one unique element of a set with two or more elements of the other set. Two or more elements of the other set. Okay, then draw this one, one to many. Okay, then the last type of relationship, it's many to many. So it's many to many relationship. So what is a many to many relationship? It's like a combination of many to one and one to many. So that is what we term as many to many. So here you can see that one element has been assigned into a few elements of the other set. And meanwhile, you can see that few elements of this set has been assigned to one element of the other set. Okay, so here it's a combination of the one to many and many to one. Meanwhile, this one-to-one relationship can exist everywhere. I can one-to-one හැමතැනම ඉන්න පුළුවන්. That is okay. ඕන තැනක one-to-one පේන්න පුළුවන්. But we term this based on this special case. So here many to many means one element or more of one set is connected with one element or more elements of the other set is what we term as a many to many relationship. Okay, so under this, right, a relationship that connects a relationship that connects one or more elements, one or more elements of a set, one or more elements of a set with one or more elements with one or more elements of the other set with one or more elements of the other set. Okay, then draw this one, and here you can see this one to many instance relationship and even the many to one relationship. So in many to many, you can see both one to many and even many to one. Okay, so after this, put a red star mark and write in a normal pen. After this one, put a red star mark in general and write in a normal pen. A one-to-one relationship, a one-to-one relationship can be seen, a one-to-one relationship can be seen in any type of relationship. A one-to-one relationship can be seen in any type of relationship. Okay, so you can see one-to-one in any type of relationship. So that's okay. Okay, so now we have to talk about the main topic, functions. So we are not talking about relationships. Our main one is functions. So I'll keep this in this way. So when I say the definition of a function, you will realize, okay, that is the same thing what we consider to be a relationship. Because what is a function? A function is a mathematical rule that connects elements of one set to elements of another set is what we call as a function. So if I consider in this way, this is a function. So this is a function. I know the question that you are asking me, so you will be asking, so that is the same thing what I explain as a relationship. So now I'm telling you what is a function. A function is a mathematical rule that connects elements of one set with the elements of another set is what we call as a function. So same thing, so you are getting the same idea. Listen. Sit properly. Doesn't know, yeah? Like you have to be in a very fresh mood because you are coming, most of the students are coming from home. No? After school starts, when you are coming directly from school, then it is okay if you might feel a bit sleep in the first hour. I can admit that one. Because you are going school early in the morning and you are coming after like 6 hours, even though you learn or not, you stay at school till 1:30, no? And then you come at 3 o'clock with this hectic mode. So that I understood. But here, like most of the students, like only more, not even less than 5 students have gone school and come here. So here now I expect you to be in the fresh mode. Okay, nidimata in the bag. Okay. So don't stay in these positions. These are sleeping positions. When you just keep this jack, me jack ke home in there no. Artistic way. You keep it in artistic way in this way. Okay, so don't stay in that way. So here, what is a function? Function is same as the relationship. If function is having the same definition as a relationship, why do we have two words, functions and relationships? So here I just gave a special thing that I call this as a mathematical rule. A mathematical rule that connects the elements of this set and the elements of another set is what we term as a function. But there is a limitation when it comes to a function. So I told you there are 4 types of relationships. But there is a limitation when it comes to functions. So I'll use this example. I'm taking the example that this set, okay, I'm taking the example of this set. Here we have the son. Son, no sons and daughters, you can put it in that way. And here I got the father. The father's set, and here is the son's set. Okay, so here one son is having one father. One son is having one father. So that can happen biologically, that is highly possible. One son is having one father. So this can happen. So this can happen. So we say that this is a function. It can happen. I'm using this example because of this reason. Okay, then it goes to your mind. So it is a function. Yes, it is a function. Okay, when I come to this one, the same set. So here we are having the sons and fathers. 2 sons are having the same father. Is it possible? It's possible because that's why you are having these brothers and sisters. So it's possible. So here 2 sons is having the same father. So it is possible, can happen. So we call this as a function. So it's a function. So when it comes to this example, one-to-many relationship, so one son is having 2 fathers. Biologically, it's not possible. But we have to think about this ethical side, that there can be such instances. For example, let's say a child's father is dying when he is in a small age, and his mother get married again. So then we have this, we call it as stepfather. So there are those instances. No, even this one in the society, it's we see those instances. Okay, but biologically this is not possible. Okay, biologically whatever happens, it's not possible. Silence. Okay, so here it's not possible. So it's not a function. So this relationship is not a function. Because biologically it's not possible. Okay, so when you come to the many-to-many relationship, because of this one, so many to one is possible. But one to many, because of this one, inside we are having is something that is not possible. So even this one, we say that's not a function. So even this one is not a function. So I told you, when I tell you the definition of a function, you might get the feeling that is the same as a relationship. But when it comes to functions, there is a restriction, a limitation. A function can only be either a one-to-one relationship or a many-to-one relationship. Okay, a function can only be either a one-to-one relationship or a many-to-one relationship. Okay, one-to-many relationships and many-to-many relationships are not considered as functions. Okay, are not considered as functions. Either it should be one-to-one or many-to-one. So that's why I use this example. So when you are, I'm not giving this example, you don't have to write it, but just keep it in mind so easily you can get the idea what is a function and what is what is not a function. But when you're keeping that example in the mind, don't switch the 2 sets, okay? When you switch the 2 sets, one-to-one is a function, then this becomes a function. Because one father is having 2 or 3 sons. So don't switch the 2 sets. Okay, so being simple, one-to-one and many-to-one. So that is what we call as a function. Okay, write in this way a small topic, definition of a function. Definition of a function. Definition of a function. Okay, write in quoted commas. Write in quoted commas. A mathematical rule. Quoted commas means 66, 19 and hat high anuna mein. Okay, a mathematical rule that connects. A mathematical rule that connects elements of one set. Elements of one set to the elements of another set. To the elements of another set is known as a, write in a red pen the word function, is known as a function. Is known as a function. Okay, then continue. A function can only be a function can only be either a one-to-one relationship. A function can only be either a one-to-one relationship or a many-to-one relationship. A function can only be either a one-to-one relationship or a many-to-one relationship. Or a many-to-one relationship. Okay, so just draw this same one and show that. So this is what we call as a function. So this is what we termed as a function. So this becomes a function. Okay. Okay, then write the topic, variables of a function. So the first part of this one is a theory part. The first 45 minutes to 1 hour is a theory part, and then we will be starting problems. Okay, write the topic, variables of a function. Variables of a function. Okay, variables of a function. Okay, so this is how we name the variable. So I'll take example. So here we have the variables 1, 2, 3, and 4. And here we got the variable 0, 1, 4, 9, 16, 21 are the variables that I have taken. So the function, I told you that the function is a mathematical rule. So what is the mathematical rule that connects these two sets? This set with this set is the square. So I'm considering the square. So if I consider this 1, the square of 1 is 1. The square of 2 is 4. The square of 3 is 9 and 4 is 16. Is 16. We can even add like minus 1. And if we square minus 1, I'm getting the answer plus 1. Okay. So here it's clear what happens. We use these one as the input variables. So here we use these variables as the input variables. And this is what we get as the output. So let's say this function is a machine. And what happens, whatever goes inside, it gets squared. Okay, so when we put minus 1, what we see as the output is plus 1 is coming out. When I put 2, what comes out is 4 comes out. So these input variables, so we know, like I know, like if I ask you to write this as a function, we are writing y is equal to x squared. Because y is equal to x squared. So what happens here? We put these input values for x. If you can remember, how did you sketch the graph of y equals x squared? You consider this table. You consider this table and you took the x values and y values. And then you were putting these x values and you wrote the corresponding y values. Can you remember? So here we were changing the x values, and when I was changing the x values, the y values change according to the x value that I have used. So here x, we have the freedom to select any value for x. We have the freedom to select any value for x. But we don't have the freedom to select any value for y. Because y depends on this one. So y is the value that what we get depending on this one. If we take minus 1, it's 1. If I take 2, it's 4. So it's clear x has the freedom to take any value, but y doesn't have the freedom to take any value. Y is dependent on x. Because whatever the value that we take for x, according to that value, y should be changed. So that's why we termed x or the input variable as the independent variable and y or the output variable as the dependent variable. So the word, you know the meaning of dependent and independent, that you know. No? So what is meant by independent? When you are like you can live your own. So you are not independent. You are highly dependent on your parents. You might think that you are not dependent, but even the data card you are using is from your parents' money. So you are like highly dependent. If you consider Sri Lanka as a country, is it dependent or independent? As a country, we gained the independence in 1948, but as a country, we are totally dependent. Okay, whatever happens, like we have to stay in a like in a midway. For example, there's a war between Russia and Ukraine, and then Sri Lanka gives an announcement that we are not supporting in any country. We neither support Russia nor Ukraine. We are going to stay in a mid policy. The reason is we have taken so many donations from Ukraine and even from Russia. So there's no any way that we can support anyone. When America and Iran happens, a war between America and Iran, we are saying that we have kept attention, we are focused, we have kept our eye on the war. So we only can keep the eye. There's nothing else that we can do. America is Iran. What can we do? We can only if something tragedy happens, we can put this like a sad notice. That's all what we can do. Nothing else we can do. But we can't even support any of the countries because if we support America, Iran will restrict all the donations that they have given for us. And if we support Iran, America will be increasing all the taxes and all that they have imposed on us. So that's why Sri Lanka is highly not a normal dependency. It's like highly dependency on the entire world. Like a child is dependent on their parents. Clear? So what we consider as dependent and independent, dependent can't be like a dependent one is it changes according to the impact of the independent variable. Independent variable has the freedom to change accordingly, but the dependent variable changes based on the independent variable. So I'll keep things simple. The input variable is what we consider as the independent variable, but the output variable changes according to the input variable. So it's dependent, so we call it as the dependent variable. Okay, so write it this way, variables of a function, write it this way. The variables of a function, the variables of a function can be termed as below. Can be termed as below. Okay, so then after that one, using a black pen, write independent variable within brackets x. Using a black pen, write independent variable within brackets x, and in front of that write it this way. The input variable of a function. In front of that write this, the input variable of a function. This variable has the freedom to take any value. This variable has the freedom to take any value. Any value. Okay, the next line write same way, dependent variable y. Using a black pen, dependent variable y. And then write it this way, dependent variable y, and write it this way, the output variable of the function. The output variable of the function. Output variable of the function. This variable varies according to the input value. This variable varies according to the input variable. Okay. Okay, now look at this through. These two are the main two types that we got, the independent variable and the dependent variable. Okay, so it's clear. But now we look at this example. Here you can see that this one, like this dependent variable has been assigned to an input value. So this one has been assigned to an input value. And all these four variables, all of these are dependent variables. So this entire set, all these variables are dependent variables. So simply, this side are independent variables and these are dependent variables. So even in these dependent variables, you can see some of the dependent variables have been assigned to this input value. But there are some variables that have been left over. No? You can see there are like two variables here that have been left over. So here 0 has not been assigned to an independent variable. 21 has not been assigned. So now all these are dependent variables, and even inside that we are having this special case where all these dependent variables are connected to an independent variable. So we name this variables, even inside the dependent variables, we name these variables as the image. So why do we use the word image? You know, when you go to a mirror, you don't see yourself, you see the image of you. So that's why we say that this is the image. So here, when we put an input variable to a function, what we see as the output is 1. So here, when you put this input variable to a function, what we see as output is 1. So what we see is what we call as the image. So other than these two, there's another one that we need to learn. What is an image? Image is a dependent variable of a corresponding input variable. For example, the output variable, the output value of an input variable or input value is considered as the image of that one. So 0 and 21 are not images. Clear? 0 and 21 are not images. Only these are images. The dependent variable of a corresponding independent variable is termed as an image. So image is always a subcategory or subset of this dependent variables. So all are dependent variables. Inside that, we are having a subset called images. Clear? Hands up if that is clear. Okay. Can't sleep, huh? Okay. Make sure that you keep him like without sleeping. Okay, next one, write the third one, image. The last one, image. So we have independent variable, dependent variable, and then the image. So write in this way, the corresponding dependent variable, the corresponding dependent variable, the corresponding dependent variable of an independent variable of an independent variable. That's all. So what is the image? The dependent variable, the corresponding variable of an, the corresponding dependent variable of an independent variable. That's what I gave. No? The corresponding dependent variable of an independent variable. Okay. Okay, then write this example and mark them. These are independent variables. These are independent variables. All these are dependent variables. Inside the dependent variables, we are having this special category which have been assigned to an independent variable. We call them as images. We call them as images. Silence, silence, silence. Silence, silence, don't talk. Don't talk and just copy paste the board. Small stuff, these are not like complex ones. They have been different words that you need to understand the meanings. That's all. independent variables, dependent variables, and the images. Okay. Okay, now write the next topic, sets of a function. The next topic, sets of a function. So these are just words. These are just words. Write the next topic, sets of a function. Okay. Okay, now listen, 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 listen. So here it's clear. Listen, listen. This one, we have the independent variables. Okay. And here we got the dependent variable. So inside the dependent variables, there is another subcategory which has been assigned to a particular input variable, this set. Okay, I told you these are the images. So here we got the independent variables and here we got the dependent variables. The set consisting of the independent variables, we term it as the domain of the function. So it's the domain of the function. Okay, domain. And how do we denote it? It's a df. F is for the function, domain of the function. The set that consists of the dependent variables, we call it as the codomain. And we denote it as CODF, not Call of Duty, it's codomain. CODF, F stands for the function. And there is another name that we call this one, the set that consists of the images. So this set consists of, like, only consists with images. No? So this one, we call it as the range of the function. So this is the range and it's denoted as RF. Clear? So these are like just words, are not hard stuff, not complex stuff like quantum physics, God's particle, nothing like that. The simple words. Okay, you might be thinking that these are something hard according to the way that I'm speaking, but these are simple words, domain, codomain, range, that's all. Okay, even though like this has been taught in O levels, you still can easily understand. Nothing A levels, just definitions. Okay, so domain, codomain, and the range. Okay, now tell me, according to your knowledge of sets, the range is always what of the codomain? The range is always a subset of the codomain. A range is always inside the codomain, so it's always a subset of a codomain. Okay, so then write the topic that we wrote is sets of a function. The same way that you wrote these independent variables, dependent variables, using a black pen, first write domain, within brackets df, domain within brackets df, within brackets df. In front of that, write in this way, the set consisting of independent variables. The set consisting of independent variables. The set consisting of independent variables. Okay, then repeat the same thing to codomain and range. CODF RF. Codomain is a set consisting of dependent variables. Range is a set consisting of images. And then draw this diagram. Complete the note by your own. Write codomain and range. Silence, silence. Okay, then write the next one. We had variables of a function, sets of a function, notation of a function. The next one, notation of a function. Okay, so this is the main notation of a function. Is we say this in this way: if the independent variable x is given as the input value of a function, the output is y. The output is y. Okay, so y equals fx is the main way that how we denote a function or the notation of a function. So here x is the independent variable, x is the independent variable and y is the dependent variable. Y is the dependent variable. Y is the dependent variable. Clear? So x is the independent variable and y is the dependent variable. So this is one notation, the main one. And there is, so normally we use this f, like the function can be y equals gx, fx, mx, qx. You can remember in polynomials we did those. No? But normally the first thing that comes to your mind is f. I have spoke about this previously. When I ask you to think about a variable, the first variable that comes to your mind is x. You don't think about, okay, k. Normally, if you are an ordinary person, what comes to your mind first is x. And if I ask you to take a second variable, you take y. So that's why x, y, z. That's why we take x, y, z. If I ask you to think a variable for a time, what is the first variable that comes to your mind? It's t. You don't say x for time. So that is how we work. So that's why we use this f. It can be gx, px, any x, okay? And there's another notation, but in questions you might see this, a bit old one, is the function connects, we write this in this way, x to y, capital X to y, capital Y. So capital X denotes the domain, capital X denotes the domain, capital Y denotes the codomain. Capital Y denotes the codomain. So the function connects the domain X and the codomain Y. So that is another notation, but not a main one. This is the main one. Okay, write in this way under the notation of a function. Write in this way. A function can be denoted in the following manner. A function can be denoted in the following manner. Okay, write this one and highlight it using a red pen, but this one you don't have to highlight it, just write fxy. Write both y equals fx and this one, both. Okay, I'll give you 1 minute, drink some water, and if there's anything that you missed, complete those. Okay, write the main topic of the lesson. Silence. Okay. Finding the domain of a function. Write the topic. Finding the domain of a function. Finding the domain of a function. So this is the main one. So when we are talking about the functions question, there are two main things that will be tested. One is to find the domain of the, listen, pay attention. Okay, one thing is find the domain of the function, and the other one is to find the range of the function. We can't find the codomain. I'll explain after we complete this domain part. So there are two main things that will be tested. First one, find the domain of the function, and the other one is to find the range of the function. So what is meant by the domain? So let's say we are having a function that y equals fx. So I'll write a simple one, y is equal to x squared. Okay, this is one function, y equals 2x. And I'll take another one, y equals x squared. And I'll take another example, y equals 1 over x minus 1. Okay, now listen to this, okay? One small thing. So what is meant by, what do we mean by finding the domain? Is we need to find the set of x or the x values. We have to find the set of x or the x values that makes y a real number, we need to find the set of x values that makes y a real number. That defines y or that makes y a real number. So if I think of values that I can substitute for x, if I put x equals 1, we get 2. X equals half, we get 1. If equals x equals minus 3, it's minus 6. So now it is clear, whatever the value we consider for x, whatever the value we select as x, we will be getting a real value for y, no? The y's value will be real. Because there's no anything that we might think it might be undefined or not real. So here, we say that we can substitute any x value here. We say that we can substitute any x value here. Even in this case, like whatever the x value we put, let's say you put in minus 2. I'm getting minus 2 squared is 4. I put minus 3. Minus 3 squared is 9. So whatever the value we put here, we substitute here, we get a real value. කියන්නේ මෙතන x ට මොකක් දැම්මත් y වලට normal එකක් එනවා. Real value එකක් එනවා. But in this case, let's say I'm putting x equals 4. So when you put x equals, hey, pay attention. Okay, last warning. If you're like really sleepy, you can go and wash your face and come. Or you can take a wash and come. It's even okay. If you have a towel. Okay. So pay attention. Nah? Pay attention to the phone, if not to the phone, to a board. Okay. Okay. So if I put x equals 3 here, 3 minus 1 is 2, I get the value half. I get 1 over 2 half. If I put x equals 5, what I get 1 over 4. So I get the value 1 over 4. If I put x equals 0, 0 minus 1 is minus 1. Then I get 1 divided by minus 1. I get a real value minus 1. But tell me what happens if I put x equals 1. If I put x equals 1, the denominator 1 minus 1 becomes 0. I have clearly stated that if the denominator becomes 0 in maths, we say that that is not defined. If the denominator becomes 0, I have clearly stated that is not defined, not infinity. Okay, not infinity. If the denominator is 0, that is not defined. Means it's not real, not defined. So in these two cases, you saw that we can substitute any x value, any real value. X can be any real value. But in this case, x can be any real value we admit, but x can't be 1. X can be any value, but it can't be 1. ඕන value එකක් ගන්න පුළුවන් හැබැයි එක වෙන්න බෑ. Because if it becomes x equals 1, it is undefined. Clear? It is undefined. Okay, then in this instance, we say the domain is the set of x such that y is real. So in this case, x can be any real number. X is an element of the entire real number set. Or you can write the domain is the set of x. It's equal to the entire real number set. Even in this case, the domain, it can be any value, x can be any value. So you can write it either x is element of the real number set, R is the real number set, or you can write the domain df is equal to the real number set. Because the domain is the set of x or the set of values that x can take. But when it comes to here, it's clear that x can be any value, x can take any value, but it can't take 1. So how can we write it? I'm writing it in this way. X is an element of the entire real number set. X can be any real number, but it can't be 1. So how can I write it? Minus 1. So I have taken out 1 from the real number set. A real number set taking eka inkal, I have taken out 1. Or else you can write that the domain is equal to the entire real number set excluding 1. So I have excluded 1 here. Okay, now you tell me, if I write the function So y can even be given as fx, okay, because it's the same. Y is equal to fx. Y is equal to fx, so it's the same. Even in the tutor, I think they have given as fx. So even though it's fx or y, that doesn't matter to a final answer. Okay, now let's say you have been given the function 2x over x minus 1 and x plus 2. Okay, now tell me, I told you the denominator cannot be 0. Because if the denominator becomes 0, tell me. If the denominator becomes 0, it is not defined. It's not defined in math. So here, in this case, we saw that x was not equal to 1. X can't be 1. In this case, x can't be 1 and even it can't be minus 2. No? Because if it becomes 1, this becomes 0. If it becomes minus 2, this becomes 0. So we have to exclude the values that make the denominator 0. We have to exclude the value that make the denominator 0. So in this case, how can you write the domain? You can write the domain in this way. X can be any element. X can be any element, but it cannot be 1 and minus 2. So you have to exclude 1 and minus 2. You have to exclude 1 and minus 2. So you can write df is equal to the real number set, but we have to exclude 1 or minus 2. Okay. So it's really easy because in our syllabus, there are only two things that we need to consider. One thing is you have to check whether there is a denominator in the function. One thing you have to check whether there is a denominator in the function. If there is a denominator, the denominator can't be equal to, tell me, if there's a denominator, it can't be equal to 0. So when you write in the domain, you have to exclude the values that makes the denominator 0. Understood? When you write in the domain, you have to exclude the values that makes the denominator 0. And the other instance that I'll be discussing after this one, if there is a square root, what happens? So that is the next thing that we have to discuss. So you have to only consider about 2 points. One thing, whether we have a denominator, and the other one is whether we have a square root. If the function, if in the function there is no any denominator or no any square root, in the function, if there's no any denominator or no any square root, again, may function එකේ denominator එකකුත් නැහැ, square root එකකුත් නැහැ, then your domain, can't look at the phone, just look at the board, okay, then your domain becomes the entire real number set. Clear? The domain becomes the entire real number set. If there's no any denominator and no any square root, මේ වගේ normal function එකක් නම්, the domain becomes the entire real number set. Clear? Hands up if that is clear. Okay, so we gave the topic finding the domain of a function and write in this way. The set of x values, the set of x values such that the function within brackets y value such that the function within brackets the y value, okay, is defined as the domain of the function. Is defined as the domain of the function. Is defined as the domain of the function. Okay, next line. When finding the domain of the function, we have to concern about the following two instances. We have to concern about the following two instances. Under that, write the first one. Write the first one. The function consists of a denominator. Function consists of a denominator. Function consists of a denominator. Second one, function consists of a square root. Function consists of a square root. Square root. Okay, write in the next line. Write it this way. If there is no any denominator, if there is no any denominator, or a square root in a function, or a square root in the function. Okay, so what am I going to write is, I'm going to say you that if there's no any denominator or no any square root, then I'm going to write that the domain of the function becomes the entire real number set. But I'll be using a word mostly because the reason there are functions, there are so many functions in maths, even though that there is no any square root or no any denominator, but the domain is not the real number set. In maths වල වෙන functions තියෙනවා අර square root එක හිටියේ නැතත් denominator එක හිටියේ නැතත් domain එක real number set එක නෙමෙයි. But in our syllabus we don't have such functions. Okay, so make that sentence mathematically correct. I'm including this word mostly. So what I'm going to say that mostly the domain becomes the entire real number set. But in our syllabus, if you don't see a denominator, if you don't see a square root, you can directly take the domain as the entire real number set. Okay, but I'm using the word mostly to make it more mathematically correct. Understood? What did you understand? There are some functions, even though there's no any square root. Okay, what did you understand? Tell me. There are some functions, even though there's no any denominator or a square root, but still the domain is not the real number set. Okay, there are functions. For example, if I consider y equals log a to the power x. Okay, y equals log a to the power x. So here, can you see a denominator? Can you see? Either you should learn or you should let your friend learn. You can't be a suicide bomber, okay? You are not even learning and you are not even let that other guy learn. සිංහලෙන් ගියොත් එක්ක ආයි කෙනෙක් ගන්න ඕනේ නැත්නම් යාළුවට කෙනෙක් ගන්න ඕනේ. මරාගෙන මැරෙන්න එපා. You are paying 5,000 not to suicide, no. And even he is paying 5,000. And you two are playing like two grade 2 kids after paying like 10,000 and come in here. And when I see, like, I can see like two of them are playing like grade 2 kids. Okay, can't see, pay attention now because I'm not chill all the time. If I see that when I'm in a chill mood, that is okay. But if I see something like that in a tempered mood, in a bad mood, I might react, okay? Because I'm not chill every time. I'm even human, no? So there we are having not like mood swings, but we are having different these tempered situations. No? Okay. Okay, so here, now listen. So we'll be talking about this later when we are talking this logarithm. Even that one is a topic in the TUT. So when you consider y equals log a to the power ax, now tell me, can you see a denominator here? No. Can you see a square root? No. But even in this one, we don't say that the domain is the entire real number set. So this one we will be discussing when we are doing logarithm. It's not the entire real number set. It's the positive real number set. It's the positive real number set. Okay, so like there are some functions. Okay, so so where did I stop? If the denominator does not consist, like if the denominator if there is no any denominator or square root in the function, mostly, write in a black pen, the domain is the entire real number set. The domain is the entire real number set. The domain is the entire real number set. Okay, do the first three questions in the tute, page number, the page number starts from 11, so it's page number 15. I don't know how did the first pages miss the page number. So there is a page number 15. Page number 15, question number 1. Do the first three questions. Page number 15, first question. Not anything in the board. Just do the first three questions. Silence, silence, silence. First question, first three questions. Just write the domain in this way. So initially write both these, but when it comes to a exam answer, just write only one. Either x is element of R or df is equal to this. Okay, so in the first three questions, the domain is the real number set. So that is clear. Okay, write number 1 using a black pen. So we are under the topic finding the domain of a function. After writing the first three, write number 1 using a black pen. Functions consisting of a denominator. Write number 1 using a black pen. Functions consisting of a denominator. Functions consisting of a denominator. Okay, functions consisting of denominator. Okay, then write it this way. As we know, if the denominator becomes 0, the function is not defined. The function is not defined. The function is not defined. Therefore, when writing the domain of such a function, when writing the domain of such a function, we have to exclude the values. We have to exclude the values which make the denominator 0. We have to exclude the values that make the denominator 0 from the domain. Okay, then first write these two examples. First write this one, the bottom one, and then write the top one. First write this one, and then this one. So this is how we exclude a value. Okay, you have to use these curl brackets. So this is how we exclude a value. It can be any real number, but it can't be 1. First write this one and this one. Okay, do question number 4, 5, and 6 in the tute. Main question 1, sub questions 4, 5, and 6. Okay, so this one, Same like in the question that we took, x can't be 1, no? So x is not equal to 1. So how can you write it that fx, the domain is x is element of any real number, but it can't be 1. It can't be 1. Or you can write that the domain is equal to the entire real number set minus 1. Clear? So here the domain, you can see we have x plus 1, which means x can't be equal to minus 1. So x is element of R minus 1. Or else you can write that the domain is equal to R. The domain is equal to R minus 1. You can either write this in this way. Okay. Okay, so this one is in the same because it's x plus 2 plus 1. So here even the same domain, because we can see a denominator, the denominator can't be equal to minus 1. So here even when you write the domain, it's x is element of R minus 1. So this is not a normal bracket. Okay, this is a set notation. In this case, this minus minus doesn't become 1. No? It doesn't become R plus 1. It's not a normal bracket. It's a set notation. Clear? No? So whenever you can see a denominator, take out the values that makes the denominator 0. Clear? Okay, write the next one, number 2. Number 2, functions consisting of a square root. Functions consisting of a square root. Functions consisting of a square root. Okay. Okay. So if you can remember, we did this lesson called numbers, no? So we did this lesson called numbers, and I told you there are two types of numbers. Real numbers and other one is like unreal or imaginary numbers. So the entire number set can be divided into two numbers, real and imaginary. Okay, now tell me what is a real number? Tell me what is a real number? Yeah, so one definition is a number that we can denote on a number line. Yeah, the main one is when we square a real number, we are supposed to get a positive answer, but that can be 0. So that is the basic definition of a real number. If you take a real number and square it, you should get a positive number, but you can get 0 because when you square 0, the square of 0 is 0. So all the numbers that we are working are real numbers. For example, 1, 2, minus half, this root 2, all are real numbers. Because when you square all of these numbers, you are getting positive values, even 0. But imaginary numbers is the opposite of real numbers. When you square an imaginary number, you are getting a negative value. So I know when I just mentioned when you square a number that you are getting a negative value, a number doesn't come to your mind at once, because if you think about any number, when you square it, you are getting a positive answer. But if you square numbers like this, root minus 2, when you square this number, it's clear the square root and the square cancel off and you get minus 2. So when you square this number, the answer is minus 2. So those numbers we call as imaginary numbers. So when we are talking about functions, it's clear. When we have a square root, now let's say we are having fx is equal to x minus 1 square root. I think this is question number 7. Okay. So this is the function that I got. Fx is equal to square root x minus 1. Okay, now what we know that if the number inside the square root is negative, we know if the number inside the square root is negative, it's not a real number. No. It's not a real number. The square root එක ඇතුලේ තියෙන එකන plus නෙමෙයි න. If it is negative, it is not a real number. We are talking about the values that we can put to x such that the function is positive. Because of that one, if we have a square root, what is inside the square root should be a positive value. What is inside the square root should be a positive value. This should be a positive value, which means your domain is x is greater or equal to 1. What is your domain? That x is equal or greater to 1. And even you can denote this using the set notation. You can denote this using the set notation. So how can you write this set notation? X is element of square bracket 1. It goes up to infinity. So how can you write this? X is element of square bracket 1 and it goes up to infinity. Okay, so this is the domain of the function. So when we have a square root, you need to consider that the expression inside the square root should be positive. So we have to select the domain such that the expression inside the square root is positive. Clear? So then x minus 1 is equal or greater than 0, can be 0, x is greater than 1. So this is the inequality notation and this is the set notation. Okay, so we have written the topic, the function consists of a square root, write in this way. The expression inside the square root, should be positive within brackets, can be 0, should be positive within brackets, can be 0, if the y value should be real. If the y value should be real. If the y value should be real. Therefore, when finding the domain of such a function, finding the domain of such a function, we need to consider that the expression inside the square root, is right in this symbol, is greater or equal to 0. You can just continue, is greater or equal to 0. Greater or equal to 0. Okay, so this is how you write it. So you can even stop from here. But if you want to write the set notation, this is the marked area. So the set notation is 1 up to infinity. So you can directly do question number 7 and then do 7, 8, 9 and 10. Do the questions 7, 8, 9 and 10. 7, 8, 9 and 10. Okay, so this one, we have the square root and I told you whatever that we got inside the square root, silence, it should be greater or equal to 0, which gives you that x is equal or greater to 2. So you can either keep it this way. If you write the set notation, x is element of 2 and it goes up to infinity. To write the set notation, that you don't have to draw the number line every time. Okay, I just drew it. So then it is clear, but you can directly write the set notation even. Anyways, write in the domain, one of these is enough. Okay, you don't have to write like both. Either keep it as inequality or as a set notation. Okay, now when it comes to here, normally what we write as the domain, we are having a square root, no? We are having a square root. Since we are having a square root, what I normally write is x minus 1 is greater or equal to 0. But there is a small thing that we have to consider here. Here it's in the denominator. No? So from the other hand, the denominator can't be equal to 0. So this is what we consider when we only consider the square root. But since it's in the denominator, we know that the denominator can't be 0, which means x is not equal to 1. X is not equal to 1. Therefore, when we are writing the domain, we have to take out this equality. Because if it is a normal square root, it's equal to 0, can be accepted. But here, if it becomes 0, it's in the denominator, the function is not defined. So here, x is not equal or greater, it's x is greater than 1. So if you write it as a set notation, since there's no inequality, x is element of normal bracket 1 goes up to infinity. Clear? It goes up to infinity. So when we have this denominator, when we have the square root in the denominator, we have to consider both. Okay, we have to consider both. Okay, so then do question number 10. If you have done this correctly, good. If you have done any mistake, even correct that in question number 10. But done it properly, good. Okay, so even here, since the square root is as the denominator, it can't be equal to 0. So x is not equal to minus 2. X is not equal to minus 2. So when you consider the domain is x minus x plus 2 is greater than 0. So x is greater than minus 2. Clear? Set notation, x is element, normal bracket minus 2. It goes up to infinity. Clear? X is minus 2. Infinity. Has a book got question number 10 correct? Okay. Okay, then do write the set of this one. Fx is equal to 1 over x minus 1 plus 3x over x plus 1 square root. Okay, so here, listen. Here this says that we are having x minus 1 in the denominator, which means x is not equal to 1. And here x plus 1 is in the denominator, which says that x is not equal to minus 1. So that is clear. But what we get here is if you consider the square root, the term inside the square root should be greater or equal to 0. But we know, since it is in the denominator, you have to take this equality. So what do you write as the answer? It's x is greater than minus 1. So that is clear. Now when you mark this answer in a number line, you have minus 1 and you are telling me that x is greater than minus 1. You are telling me that x is greater than minus 1. X is greater than minus 1. But if you look at this clearly, there are two values that we have to take out. No? One is minus 1, which we have taken out. The other is 1. So x even can't be 1. So not only minus 1, x can't be 1 because it's in the denominator. So we have to even take it out. Or we have to even take it out. Okay, so this is your domain. So how can you write it? So this is your domain. X becomes greater than minus 1, but we have to take out 1. So what is your domain? If you go with the inequality notation, x is greater than minus 1, but less than 1, or x is greater than 1. So this is if you write the inequality notation, this inequality and this one. If we go using the set notation, x is an element of what is this set? minus 1 up to 1, union, what is this set? 1 and it goes up to infinity. 1 and it goes up to infinity. Clear? So you have to write these two. Either it can be inequality notation or set notation. So make sure even you take this range, if there are values that we have to take out, you have to take out those values. Okay, hands up who understood this one, this question, who understood? Hands up who understood? Okay. So when I say who understood, like if you didn't understand, you don't have to raise your hand. But if you understood, raise your hand, because like I consider if there are like few students who didn't understand, I need to explain it again. So if you understood, really if you understood, then raise your hands, okay? Okay, then after this, do this one. Fx is equal to 1 over x plus 2 plus x plus 7 square root. Okay, find the domain of this one. Okay, so this one, there is a denominator. So when there is a denominator, it cannot be equal to 0. X is not equal to minus 2. Okay, we have the square root. What is inside the square root should be greater than 0, but here it can be equal. So x should be greater or equal to minus 7. So make sure you mark it in a number line because there are some values you have to take out. So here it's greater than minus 7. But it's clear that it cannot be minus 2, which means you have to take out minus 2. Which means you have to take out minus 2. Okay, now this is your domain. How can you write the domain? Or your domain is equal to, okay, if you write the inequality notation, x is greater than or equal to minus 7, less than minus 2, or x is greater than minus 2. And if you write the set notation, if you write these two sets, square bracket minus 7, minus 2, and minus 2 up to infinity. So what I have written here, I have considered these two sets. But there's another way that you can write this in this set notation. What you can do is this. Now look at this. Now tell me, what is this entire set? Forget about this minus 2. Forget about this minus 2. What is this entire set? Entire set. Minus 7 up to? Tell me, minus 7 up to infinity. So what is this entire set? It's minus 7 up to infinity. You can take out this minus 2 from this entire set. So there is another notation. This is this entire set. You can take out this minus 2, but make sure you put this curl brackets because it is an element from this entire set. So any notation is correct, okay? So if your set notation, brackets are correct, all these are correct. Okay, good. Now, do question number 12. Now do question number 12. And if there's anything unclear, you can ask from me when I come. Do question number 12. Okay, so what I ask you to do is question number 12. Okay, now look at this. What we have is, again, listen. Fx is equal to x squared minus 1 square root. So this is what we got. No? Okay, so when we are finding the domain, I told you, when we have a square root and it is not in the denominator, which means the square root function should be greater or equal to 0. So that is if it is not in the denominator. So I saw like many students have done this in the correct way. So when you consider x squared is greater than or equal to 1, and what I want the range of x, so I can consider the square root. And then I get that x is greater or equal to 1. So you can either keep your answer in the inequality notation or you can use the set notation. So what is this set? x is element of square bracket 1 and it goes up to infinity. So you can keep your domain in this way. I told you when we have a square root function, the square root function should be what is inside the square root should be equal or greater than 0. Okay, hands up who got this answer. This domain x is okay, good. Okay, silence, silence. Okay. Again, hands up who got this answer before I did this on the board. Who got it before I did it on the board? Okay. Okay, good. Is this correct? This is correct. If this is correct, why did we do a lesson called inequalities for 2 weeks? Why did we learn something called sine curve methods in inequalities? If this is correct, if this would have done this easy, why did I explain something like sine curve method? Can we consider the square root of the inequality in either sides? This is wrong. This is wrong, Bharati. Okay, so this is not how you get the answer. Silence, silence, wait. Hare, okay, silence. So when I have to solve the silence, when I have to solve the inequality x squared minus 1 is greater than 0, we have to use the sine curve method. So what is the sine curve method? Factorize this. X minus 1, x plus 1. Take your number line. Mark the values that make these 0. This becomes 0 when x equals 1. This becomes 0 when x equals minus 1. Mark the values that make these 0. So I'm explaining this for the newcomers, not for the students who were there. Okay, so then we are having 3 ranges. So think of a range. If you consider this range, think of any number of that range. Take minus 2. So when you take minus 2 minus is minus. Minus 2 plus 1 is minus. So minus minus gives you a plus. If you think of a number between this range, if I go with 0, 0 minus 1 is minus and 0 plus 1 is plus. So minus into plus is minus. Think of a number greater than 1. Even I'll be explaining the next question. So anyone, a newcomer who couldn't understand from this one, you can understand easily from the next one. If I consider something greater than 1, if I go with 3, 3 minus 1 is plus, and even this is plus. So this is plus. So after marking these signs, we need to find the region that is greater or equal to 0. So it is this region and this region that we have to consider. We have to consider the positive region. We have to take the region where it is positive. So what is my domain? X is less than or equal to minus 1 or x is greater or equal to 1. So this is your domain. If you write the set notation, x is element of, what is this set? Minus infinity coming up to minus 1, union, starting from 1 going up to infinity. So anyone, a newcomer, like who couldn't understand this, like try the best to understand, but you will get it when I even do the next example. So this is my domain. So this is my domain. You have to consider the number line, the sine curve method to get this. Okay, hands up who got the answer this way? At least few exist, no? Okay, good. Okay, do this and then do question number 11. Okay, so when you take question number 11, it's 9 minus x squared. No? So what is inside the square root? It should be greater or equal to 0. So now we are not going to take it to the other side and square root it. You have to factorize. So what is the factorization? It's difference of 2 squares. So 2 minus x into, 3 minus x into 3 plus x. Then take a number line, anyone who were not in the class when we did this lesson. So then mark the values that make these factors 0. This becomes 0 when x equals 3. This becomes 0 when x is equal to minus 3. And then think of any number in this range. If you take minus 4, substitute it here. 3 minus minus 4 is 3 plus 4 and 3 minus. So this is plus, this is minus. That means the product gives you minus. So that's what you have to do. Think of a number in this range. If you take 1, this is even positive. Even this is positive, which gives you the product is positive. And then think of a number greater than 3. This will be negative, but this is positive. The product becomes negative. And then look at the inequality. You are supposed to find where it is positive. I won't repeat. And this is the only class in 2027 that I need to repeat this much, like stay silent and stay silent. In the single and medium class, we are having 2 groups and 215 each group. The class is like super silent. Throughout the entire 4 hours, I only like use like It's 2027, like you are having a good discipline, okay? But in this class, I have to repeat that like once in every 5-10 minutes. I won't be repeating it again and again. When I'm talking from the mic, don't talk. That's all. Even though you understand, even though you have finished this or not, අහගන්න දෙයක් නැති වුණත් අහන් හිටිනතරට කමන්නේ කතා කරන්න එපා. You better come to a single medium class and see it. I don't like give this much of effort to like keep the class silent. Even having like more than like in this one, you having 2 groups, and even when those 2 groups are combined the same. In the 26 class, we are having like 5 times larger than this one in the single medium one. But still, throughout the class, I might be using like don't shout or like something like that. Maximum of 5 to 6 times in the 26 class even. I'll be splitting like the way that you have like sit. We have ample space, no? Then I'll give 1 row, only 2 students. Kisi awulan lesson ගන්න පුළුවන්. 1 row, only 2 students. Don't make me like make you sit in that way. When I'm talking, don't talk. එච්චරයි. ආයි කියන්නත් එපා. කියන්න දෙන්නත් එපා. Okay, so then we have to check where the ranges that it is positive. It becomes positive when it is less than -3 and when it is greater than 3. Which means you can write your domain x is less or equal to -3 or x is greater or equal to 3. If you go with the set notation, sorry, it's the mid one. So we have to go with the positive range, which is the mid one. So this range. Okay. So it is in between -3 and +3. So this is my domain. So one set x is element of -3 and +3. Okay, hands up who got this one, -3 +3 in between -3. Hands up everyone who got it. Then do this one. Fx is equal to x squared minus x minus 2 square root, that is 1. The other one is fx is equal to x plus 1 over x minus 1 square root. X plus 2 x minus 1 square root. Okay, so this one we have in this quadratic one, x squared minus x minus 2 should be greater or equal to 0. So when you factorize this, you get x minus 2 and x plus 1 is greater or equal to 0. So now even a newcomer can do this, mark the values that make these factors 0, and when you check the sign, in this sign you get that it's positive, in this one it's negative, and this one is positive. So you need to find the region that it is positive. It's positive in this one and this region. These 2 regions. So your answer should be the domain is x is less or equal to -1 O, it's greater or equal to 2. So set notation, x is the element of minus infinity to minus 1 union 2 up to positive infinity. Clear? So this is the domain of your function. And the next one is, so I'll explain this in two ways. One thing is when you have a denominator, when you have a denominator, we know even though it's inside a square root or not, the denominator can't be 0. So we can exclude that x equals 1. So that we know when we have a denominator, even though it's inside a square root or not, it can't be 1. It can't be 0. Bindu වෙන්න බෑ. හරිද? Okay, then we have a square root. The function inside the square root should be positive. So this is the same. We have done even more complex inequalities and inequality lesson. So now we have to solve this same thing. Same thing. Go with the sine curve method. This becomes 0 when x equals 1. This becomes 0 when x equals minus 2. And again, go with the same thing. Think of a sign that makes that in this range. Sorry, think of a number that in this range. If you think of minus 3 plus 2 is minus 3 minus 1 is minus. So minus over minus is plus. Think of a number in this range. If I take 0 plus 2 is plus, but 0 minus is minus. So plus divided by minus is minus. And anything greater than 1, if you take 5 plus over plus is plus. So now it is clear. So we have to take the region that is greater or equal to 0. So these two regions. Can you remember when we were doing inequalities, I told you, if we are having the equal mark here, these values should be considered, should be covered. But meanwhile, I told you, but we can't make a denominator equal to 0, even though there's equality mark here, we can't consider the denominator 0. So even if you consider only that one, you have to take out this one value. So even if you forget about this one, let's say you forget that the denominator can't be 0, but still if you apply the sine curve method in a proper way, then somehow this one goes away. Clear? So what's your domain here? It's x is less or equal than minus 2, or it is only greater than 1. It can't be equal to 1. Set notation, x is element of minus infinity, minus 2, union 1, and it goes up to infinity. Clear? So what is your domain? The domain is in this one. Okay, hands up who got the answer for this one. Who wrote this one properly? This. Good. Okay, then take a break and come. It's 5:35. Come by 5:50. Who observed when I was giving medals last week, if your name were in the top 10 list that I have posted in the group, and if you didn't get the medal last week, talk to me after the class. Okay, come by 5:50. Okay, no, silence. So under finding the domain, do these as homework. Question number 4. Mark this as homework. Question number 4. And question number 6. Main question number 4. Question number 6. And then question number 9 and 11. Question number 9 and 11. So both question number 1 and question number 11, we have to find the domain and the range, but now range will be discussing. So we have to find the domain part. We now do question number 9, the main question 9. There are two functions. Find the domain of these two functions quickly. Question number 9. Find the two domains of the functions. Okay, silence. Kadan then question number 9. 9 means main question 9. Huh? Silence, silence. Okay. Do question number 9, the main question 9. Okay, so this one, it's a similar one that what we have done before. The denominator can't be 0. So x can't be equal to 0, 1. So that we know. Because x can't be 0 and x can't be 1. And then you can write the domain based on this. So what is the domain? X can be any real number, but that is not equal to 0 and 1. That is not equal to 0 and 1. Okay, so this is the domain. So second one is we are having a square root, and inside the square root we got 4x squared plus 5. But according to what we learn when we have a square root, is the expression inside the square root should be greater or equal to 0. No? So that is what we learn. Okay, now think about the inequalities lesson. I told you x squared, something like x squared. I told you it's equal or greater than 0. No? When it is x squared, it's equal or greater than 0. Why is it equal to 0? Tell me, why is it equal to 0? Because 0 squared is equal to 0. Then I told you that x squared is equal or greater than 0, but what can you say something like x squared plus 1? What can you say something like x squared plus 1? X squared is equal or greater than 0, but even though it's 0, we are having a plus 1. No? So what can you say about x squared plus 1? X squared plus 1. This is always it's positive greater than 0. There's no any equal mark. So when we have a square term plus someone, that is always positive. Clear? When we have a square plus someone, it's always positive. Now look at this. How should we find the domain? We only can put x values that make this positive. No? Make this positive. So what did I just mention? When we have a squared plus someone, this is always positive, which means whatever the x value you substitute here, whatever the x value you substitute here, this x square, 4x square plus y, this will be positive. So whatever the x value you substitute means, we have the freedom to substitute any x value. So x can be any real value. So tell me, if x can be any value, what is the domain of x? What is the domain of the function? It's the entire real number set. Therefore, make a x වලට මොකක් දැම්මත් you are getting a positive one. කැමති එකක් දාන්න. මොකක් දැම්මත් you are getting a positive value. So since when you put anything you are getting a positive one, this is already greater than 0. X හිටියත් නැතත් වැඩක් නැහැ. This is already greater than 0. So x, you can write this for any x value, for any x value, 4x squared plus 5, it's greater than 0. For any x value, 4x squared plus 5 is greater than 0, which means the domain is the entire real number set. Your domain is the entire real number set. The domain is the entire real number set. For any x value, 4x squared plus 5, okay, it's positive, greater than 0. So you can substitute any x value here. You can substitute any x value here. Any x value here, clear. Good. Okay, then you can do the remaining things as homework. Question number, as I mentioned, question number 4, question number 6. So 9 we have done now. And question number 11, in all the functions, find the domain. Okay, question number 4, 6 and 11, all the functions, find the domain. Okay, then write the topic, codomain of a function. Write the topic, codomain of a function. Codomain of a function. Okay, codomain of a function. Okay, I told you in this lesson functions, we'll be only tested by two. One is to find the domain and the other one is range. If you look at question number 1, what is the question? Find the domain and the range. If you look at question number 11, what is the question? Find the domain and the range. In this entire tude, you don't find any question to find the codomain. There is a reason that why we can't find the codomain, I'll tell you. Now let's say we are having this codomain. So I told you that the range is a subset of the codomain. So now let's say this is one range. So this is one range. This is one range of a function. And then we are having another function. We are having another function and this is the range of that function. And this is the range of that function. And then we have a separate function. The range of that function is this. So this is the range of that function. Okay. So whatever the function we consider that we are getting different ranges. No? Even though we are getting different ranges, every range is a subset of the codomain. Every range is a subset of the codomain. So that is clear. Range it should be a subset of the codomain. So that is one thing that we need to consider. The other thing is when we have the x values, you can find the domain and find the domain means the set of x values. And now let's say the set of x values is assigned to these elements. So what I can do is I can find these elements. I can find the images because we know the function has been assigned to these dependent variables. But how can I find the elements that have not been assigned? How can I find the elements out of this? I can find the range. Making ආවේ මොනවාද කට්ටිය හොයන්න පුළුවන්. But how can I find the things that are outside? If you are, let's say if you are given a task to measure a land, ඉඩමක් මහින්න දෙනවා. You can measure that land, but how can you measure the outside area of the land excluding the land? Can you do that? You can measure the land. No? That you can measure. But how can you measure the entire? Then you have to measure this entire country. So that is not possible, no? So what we can do is only we can find a range. You can't find who's outside. That is not possible. So that is the second factor I'm considering. So I can't find a codomain. I can find a range. So that's why we are supposed to find the domain and the range. So I can't find a codomain, but I can find a range. So that is one factor. The other one is I told you, whatever the function we consider, whatever the range we get, that range should be a subset of the codomain. Can range එක මොකක් වුණත් ඒක ඉන්න ඕනේ codomain එක ඇතුලේ. Because of this reason, we say that we take the codomain is always the entire real number set. Codomain එක විදිහට අපි ගන්නේ entire real number set එක. Because if we consider the entire real number set, whatever the range we have, it will be a subset of the codomain. Clear? Because of this reason, we can't find the codomain. You will be never asked to find the codomain because the codomain of any function is the real number set. Okay, so the codomain of any function is the real number set. But I have seen some questions in term test papers. They have asked you to write the codomain. So in case if you are supposed to write the codomain, just write that the codomain is the real number set. Clear? Okay, so I told you two reasons why we can't find the codomain, because we can find these assigned values, but you can't find who is outside them. You can't find who are outside them. So you can't find the codomain. And the other one is, even though we change the function and we are getting a different range, whatever the range we get, it should be inside the codomain. So codomain is like every time, it's the entire real number set. Okay. So then the topic is codomain of a function, and write in this way. The range is a subset of the codomain. The range is the subset of the codomain. Range is the subset of the codomain. Whatever the function we consider, whatever the function we consider, whatever the function we consider, the range should always be, the range should always be the the range should always be a subset of the codomain. Should be a subset of the codomain. So to satisfy this condition, to satisfy this condition, to satisfy this condition, to satisfy this condition, the codomain of any function, the codomain of any function is said to be the real number set. The codomain of any function is said to be the real number set. Okay, then just draw this diagram, mark few ranges. So whatever the range we get, it should be a subset of the codomain. It should be a subset of the codomain. Okay, so in case, like keep in mind, if you get a question for your exam in your school, not find the codomain, you can't find, write the codomain, just write the codomain is equal to R. The codomain is equal to R. Okay, then write the next main topic, finding the range of a function. Silence. Write the next main topic, finding the range of a function. Finding the range of a function. Finding the range of a function. Okay, so we did few theories and few new terms and more problems. So let's do the range of a function. But now we have to find the range. So I told you, what is the domain? So how can we find the domain is the set of x values that make y real. Simply gatto, what is the domain? The set of x values that makes y real. So that's why I told you, when we have y is equal to x squared, we just thought about the x values that make y real. So here you can say x can take any value. You can take x value, x can take any value. So y can, like, how can you say that x can take any value? It is clear whatever the value we substitute for x, it is clear whatever the value we substitute for x, y is real. So here it's clear that we can clearly say that y is real because y has been subjected. Because when it is y is equal to this one, you can substitute the values for x and check whether y is real or not. So when y is in this way, you can substitute values for x and check whether y is real or not. Okay, so when I'm talking about the range is the opposite of the domain. Which means what is the range? The set of y values that makes x real. So what is the domain? What is the domain? The set of x values that make y real. No. The range is the opposite. The set of y values that makes the x real. That makes x real. So I told you, you can substitute different x values and check whether y is real because y has been y has been subjected. Okay, now tell me, in this function, if I want to find the range, if I want to find the range, I need to find the y values that makes x real. So if I want to check that whether x is real or not, what am I supposed to do first? I need to check whether x is real or not. So what am I supposed to do first? I need to, again, you didn't get it. Okay, now look at this. How can I clearly say whether y is real or not in these type of functions when I'm substituting different x values? That is because this is simply y is equal to this. No. So y has been subjected here. So when y has been subjected, you can say when you are substituting different x values, you can check whether y is real or not. You can check whether y is real or not. Now, when I'm finding the range, I told you finding the range means we have to find the values of y that makes x real. So you have to check when you put a value for y, you have to check whether it is real or not. You have to check whether it is real or not. So when it is in this way, you can easily see whether y is real or not. No. Okay, now tell me, if you're supposed to check whether x is real or not, what is the first thing that you need to do? You need to subject x. Because if we can subject x, we can now taking the root of both sides. When you subject x is equal to root y. So now it is x equals. And now you can substitute different values to y and check whether it is real or not. Clear? Now you can substitute different values to y and check whether x is real or not. So step number 1, when you have to find the range, is you need to subject x. So that is the first thing that you have to do. You need to subject x. Okay, write in this way. The set of y values, the set of y values that make the set of y values that makes the set of y values that makes x real is considered as the range of the function. Is considered as the range of the function. Since we have to check whether x is real, put a comma, write in a black pen, we need to subject x first. Use in a black pen, I told you, we need to subject x first. Then continue with the normal pen to find the range of a function. We need to subject x first to find the range of a function. Okay, so when we subject, now let's say you have to find the range of this one. So after you subject it, it's same as the way that you got the domain. Check whether you have a square root or check whether you have a denominator. If there is a square root, the term inside the square root should be positive. So here, what is inside this one? It's y. So y should be greater or equal to 0. So simply the range is kept in terms of y because we are finding the set of y values. So the range is in terms of y. So here it is clear y is greater than 0. Or you can write that y is element of 0 to infinity. So this is how you do this. First thing you have to subject x. Okay, I'll do another example. We have y is equal to 1 over x minus 1. I'm supposed to subject x, so cross multiply and divide by y. X minus 1 is equal to 1 over y. If you take minus 1 here, x is equal to 1 over y plus 1. Okay, I have subjected x. So after you subject x, check whether there is a denominator. Yes, there is a denominator. Okay, if there is a denominator, the denominator can't be, the denominator can't be 0. So here, y can't be 0. Y is not equal to 0. Y can't be 0. Then you can write the range. What is the range? Y can be any real number, but it can't be 0. Y can be any real number, but it can't be 0. You can either write this in this way, or as mentioned before, you can write RF. The range is equal to any real number excluding 0. Excluding 0. Okay, hands up if you understood this. Okay, then we wrote to find the range. No, next line. Right, next line. After subjecting x, after subjecting x, after subjecting x, the range of the function can be found. The range of the function can be found considering the same factors, considering the same factors, considering the same factors we considered while finding the domain. Considering the same factors we considered while finding the domain. While finding the domain. Okay, then do these two examples. So this one you can number at one. Question number one. So they have given it as fx, but fx you can write it as y. Okay. So I'll do the same question that you would. Question number one. So fx is that they have given, write it as y. They have given the function fx equals x squared, but write it as 1. Sorry, write it as y. Silence, silence, don't talk and write. QR. When you're doing the work, do it alone. So first subject x using your knowledge of subject in a term, and then check whether there is a denominator or a square root. Okay, do these questions in question number 1. The first one is what we did. Do question number 2, 4, 5 and 6. Question number 1, main question 1, find the ranges of 2, 4, 5 and 6. 2, 4, 5, 6. Main question 1. First we got the domains of each function and now find the range. Question number 2, 4, 5 and 6. Okay, question number 2. So I told you they have given it as fx but name it as y. So y is equal to x squared plus 1. We are supposed to subject x. Y minus 1 is equal to x squared. Consider the square root. Then I get x is equal to y minus 1 root. So after subjecting x, check whether there is a square root or whether there is a denominator. Then I get y minus 1 is greater or equal to 0, which means your range is y is greater than or equal to 1. If you write it as a set, y is element of square bracket 1 is go up to infinity. Clear? So this is your range. So range you have to keep it in terms of y, or else you can even write this answer. Your range is 1 infinity. Okay, then question number 4. Fx is equal to 3 over x minus 1. So y is equal to 3 over x minus 1. Your subject x, y into x minus 1 is equal to 3. So x minus 1 is equal to 3 over y. X is equal to 3 over y plus 1. So here you can see y is in the denominator. So when y is in the denominator, when you're considering the range, you know that the denominator can't be 0. Y is not equal to 0. So what is your range? The y can be any other real number excluding 0. Okay, hands up who got question number 2 and 4. These two ranges. These two. Got it? No. Okay. Then question number 5. I directly write y is equal to x plus 2 over x plus 1. Okay. Let's see how you subject x here. So I remember we had a separate lesson called subject in O levels, no? It was a separate lesson, formulas or something like that, where we had to subject variables. Okay, so how to subject x here? Cross multiply and take all the x terms to one side. So it's yx plus y. No? So take all the x terms to one side. Yx minus x is equal to 2 minus y. So y minus 1 into x is equal to 2 minus y. When you subject x, it's 2 minus y over y minus 1. So it's clear. When you subject x, what do I have? It's 2 minus y over y minus 1. If you take this yx to this side, same thing, you will be getting y minus 2 over 1 minus y. But at the end, it's clear the denominator can't be 0. So y is not equal to 1. So that is what we have to consider. Y is not equal to 1. So your range is r can be any real number. Sorry, y can be any real number, but it cannot be 1. But it cannot be 1. Okay, as about it, question number 5. Okay, so you can complete the work, do question number 6 and complete the work. Okay, so how can you subject x here? First take the common denominator, x plus 1. Then 2 times x plus 1 plus x plus 2. And then you can cross multiply y into x plus 1 is equal to 2x plus 2 plus x plus 2. Yx plus y is equal to 3x plus 4. So you have to subject x. So take x to one side. It's equal to 4 minus y. So when you take x out, it's y minus 3 over 4 minus y. So when you subject x, it's 4 minus y over y minus 3. So this is what you get when you subject x. 4 minus y over y minus 3. Then it is clear the denominator can't be equal to 0. So y is not equal to 3. Clear? Got it? Okay. So then what is your range? Your range can be any value, but it can't be 3. So excluding 3. So either you can write the answer in this way, or you can even write the range Rf is equal to any real value excluding 3. Okay. Hands up who got this range, question number 6 probably. Everyone got it? Wait, hands up. Hands up who subjected this? Who subjected this properly? Okay, let me do this. I'll give one more question because we can't end from here. Okay, after this, the entire class, I need to silence. More than 25% hasn't taken the answer. So everyone do this, find the range of y equals 3 minus x plus 1, x minus 2. Okay, so everyone find the range here. Subject x properly first, and then find the range. The same thing, first subject x. So take x minus 2 as a common denominator. Okay, so when you cross multiply, y times x minus 2 is 3x minus 6 minus x minus 1. So yx minus 2, silence, is 2x minus 7. I take x here, yx minus 2x and 2y here, 2y minus 7. So y minus 2 times x is equal to 2y minus 7. So x is equal to 2y minus 7 over y minus 2. So first thing you have to subject x. So when you subject x properly, it's silence. It's just writing that this is not equal to 2. Okay, so what is your range? Your range RF can be any real number, but it is not equal to 2. So either you can keep in this way, you can keep in terms of y, it cannot be 2. Clear? So this is your range. Okay, hands up who got this answer, r minus 2. Okay, so complete the work and get ready to go. Keep the partial fractions homework out and get ready to go, but keep the partial fractions homework that you have done, keep it out and get ready to go. Okay. Okay, 1 minute is it. So next week we will be finishing the lesson functions. So one thing I want you to do is if you can't remember, like you saw some students, some like more than 30% in the class, couldn't subject X here, this one. So if you can't remember this subject in part, like at least take your O-level textbook and go through this formula lesson. You still have the textbook, no? And just revise your knowledge of subjecting, because next week we have a thing called inverse functions. So that is entirely about subjecting X. So we need to have a clear understanding about about subjecting. So next week we will be finishing functions, and then in August we are starting the main lesson in PO Maths in grade 12, that is trigonometry. Okay, so we are starting trigonometry in August. So next week we'll be finishing functions. Okay, so bring the work that you have done. I'll be checking it here. So if you haven't done the work, or if you're a newcomer, anyway stay, because I'll be talking to the newcomers after the class. First, when I ask the girls to come, they come, bring all the work that you have done. If you haven't done, don't come and give excuses. Just stay in the place that you are already staying. Okay, and tell your parents that you will be getting late if you haven't done the homework. Okay, quickly come the girls who have done the work quickly.